Okay, here is a worksheet on moles, grams, and molecules. I'm going to do the first page, and then on the next screencast you'll see the rest of it. Alright, I'm going to read this briefly, and when it gets time to the nitty-gritty, I'll cover it in some detail. So, here we go. All of the following questions are based on lighting butane on fire. That's C4H10, for which we can write the following balanced chemical equation. 2 moles or 2 molecules of C4H10 will react with, I'll keep it to molecules, 13 molecules of oxygen. It would make 8 molecules of carbon dioxide and 10 molecules of water. To convince yourself it's true, let's check out oxygen. I see 26 oxygens on this side, which is equivalent to the 8 pairs plus the 10 singles. That means 16 plus 10 there, 26. Yeah, looks good. Note that molar ratio, 2 to 13 to 8 to 10. In the world of stoichiometry, we say those are all equivalent, as shown there. The type 1 types of questions are the simplest, mole to mole. They're one-step problems. Example, how many moles of oxygen are required to make 8 moles of water? 8 moles of water requires a little bit more, but not twice as much oxygen. So it would be 13 over 8 would be the ratio. So I'd take 13 over 8 and I'd multiply it by it. And that's hard to do in your head, so the safe way is to start with what you're given, 8 moles of water, there it is, and then do a conversion. Moles of water, put it on the bottom so it converts. A mole of water over a mole of water equals 1. And 10 moles of water, see it there, is equivalent to 13 moles of oxygen. Therefore, it's 13 to 1.3 ratio. I might have said 13 to 8. That's not correct. It's 13 to 10. Anyhow, you'll end up needing 10.4 moles of oxygen. Here's some for you. How many moles of oxygen are required to produce 240 moles of water? There it is right there. One way to do this in your head would be to say that to make 240, every 10 moles of water requires 13 moles of oxygen. Hey, this is a 1.3 multiplier. You could just do it that way. A fast method, mole ratio is 1.3 to 1, so multiply it by that and you should get 312 moles. If you don't see that, then do it the safe way. Start with what you're given, the 240 moles of water. There it is there. Recognize that this is a mole to mole conversion, which is a one-stepper. So draw your one line. It's always a good idea to write where you're going to, which would be equals blank moles of O2. I'd put that there as well. And then write your conversion using the numbers in front. Always put this unit on the bottom so that it cancels. 10 moles of water cancels, is equivalent to 13 moles of oxygen. If we did everything right, it should spit out moles of oxygen. That is what they are asking for, 312 moles of oxygen. Here's another one for you. How many moles of butane, that's this stuff, C4H10, are needed to produce 25 moles of water? Okay, this is a mole to mole conversion. You might be able to do it in your head using this idea. The mole ratio is 1 to 5, so we're simply going to divide it by 5. 25 of this only requires a fifth, therefore it's 5 moles required. Or you can do it the safe way. Start with what you're given, 25 moles of water. Recognize it's a 1 to 1 mole ratio. No. Recognize that it is a mole to mole conversion, which is a one-stepper. And then plug in your numbers, and you should get 5 moles of C4H10. Type 2 problems are 2 steps, mole to gram or grams to moles. These are like mole to mole problems with the added step of the molar masses of the substances in question being needed to be determined, right? So you can do mole to mole, but then what does that mole weigh? I hope you follow that. Example, how many grams of oxygen are required to produce 9 moles of carbon dioxide? Start with what you're given, the 9 moles of carbon dioxide. There it is. Recognize that this is a gram to mole problem, so draw 2 lines. Make sure you know where you're going to. Grams of O2, I'd throw that in there as well. And then start converting. A mole of carbon dioxide, well, 8 moles of carbon dioxide, or 8 moles of carbon dioxide, there it is, require 13 moles of oxygen, and that mole of oxygen weighs 32 grams. We're going to need 468 grams of oxygen for this reaction. This one's for you. Suggestion is to pause this video, try it on your own, and see if you got it right. How many grams of carbon dioxide are needed? No, how many grams of carbon dioxide will be produced, since it's a product, from 17 moles of oxygen? Start with what you're given, 17 moles of oxygen. Draw your two lines, equals blank grams of CO2, and convert. There it is shown completely. And every 13 moles of oxygen only requires 8 moles of carbon dioxide. Now let's restate that. If you start with 13 moles of oxygen, it will only produce 8 moles of carbon dioxide. What does it weigh? 44 grams. Punch it in, and you get 460 grams of carbon dioxide. The way this is shown, we actually did the intermediate data right there. That's how many moles it is. And there's the grams. That's the final answer, 460 grams of carbon dioxide. How many moles of C4H10 are required to produce 100 grams of CO2? Once again, a two-stepper. Start with the 100 grams CO2. Draw your two lines, equals blank moles of C4H10, and plug in, and you should end up with 0.568 moles of C4H10. You have 100 grams of carbon dioxide, 44 grams is a mole. Every 8 moles of carbon dioxide produced only requires 2 moles of butane each. It's a big reducer there. And you should get 0.568 moles. C4H10. This is small worksheet 3, mole to gram, and molecule conversions.